Alright, this video is on diverging mirrors. Just a really quick lesson on diverging mirrors. If we just go down to the bottom image here, so if we start looking at this image here, that's an example of a diverging mirror. On this side, the side that is bent, right, that's our reflective side. This is our non-reflective side where those dashed lines are. So you would see these types of mirrors in stores where they're looking for getting a wide angle mirror for the store, or looking at a parking garage where you have that curved mirror so you can see around the corner, or on buses or transport trucks where you get that curved mirror so they can see in a wide angle down the length of their truck or bus. So a diverging lens, or sorry, diverging mirror, rather, produces the same type of image every time you put an object in front of it. So if we're going to describe the result of it and go up here, diverging mirrors always produce smaller, upright, and virtual images. Doesn't matter where the object's located. So if I put the object here, or here, or here, so position A, position B, or position C, they will always produce smaller, upright, and virtual images. Now, they're called diverging mirrors because when the light comes in, reflects off the mirror, reflects off in such a way that they spread apart. So you'd have an image that is parallel to the principal axis, and then when it reflects, it spreads further apart. So this distance becomes greater. Comes in as parallel, and then reflects in such a way that they diverge or move away from that parallel axis, making the images a little bit bigger, a little bit more skewed, a little bit more stretched out. If you look in the back of a spoon, right, your face always looks a little bit wider. Now to draw that image, we draw the reflected ray so it's oriented that it goes through this focal point. So what I mean by that is if I draw my ray here, so it's running parallel to the principal axis, hits the mirror. When it hits the mirror, it's going to reflect. Now it reflects in such a way that that reflected ray lines up with the focal point on the non-reflective side. So you would have incident ray, reflected ray. This side then becomes the virtual side, so that's why I'm putting dashed lines here. And it's oriented in such a way that that reflected ray comes in and then comes back out at an angle. The angle that it comes out at is lined up with that focal point. So that's one ray. The other ray is one that runs right through the center. So if I drew that one that's represented by blue, I could take my right from my center and that ray is going to reflect out. What happens with that? This is my incident ray, comes in, hits the mirror. It hits the mirror in such a way that it actually is going straight to the center. If that's the case, then it actually reflects back on itself, just like a concave mirror. So in this case, again, the idea here is that we're going to get this greater reflection. It's going to get spread out, so the image is going to get or more skewed on this side. So again, you're looking at it from this perspective. You can also draw another ray down the bottom here. So I'm going to make this one purple. That ray is going to do the same thing. It's going to hit the mirror. The reflected image comes from the focal point. So we line that up there. So again, this is your incident ray, this is your reflected ray, and the virtual image is on that side. Right, so that's why we draw those dashed lines again. That's all you really need to know for a diverging mirror. And again, images are always virtual, meaning that the images are happening on this side of the mirror, just like a plane mirror. The image is going to be smaller, and the image is going to be upright. And again, that's the same no matter where the object's located on this principal axis. Now, the next topic is looking at diverging lenses, or double concave lenses. So far we have been dealing with what are called double convex lenses. So they have a little bubble on the outside. So this is referred to as double convex. They are a converging, oops, running out of space here, lens. Right, so images are focused on one side, so you have light that comes in, and the image gets focused on this side of the lens. So it gets bent inwards. Okay, so we've been dealing with that. We've drawn ray diagrams about that. You've done a lab on that. What we're going to focus on here is now what's referred to as a double concave. Double concave because it's bending inwards here. So you actually, when you pick up the lens, you're going to feel it dip in the middle. This is going to be, again, referred to as a double concave, right, or a diverging lens. Right, so double concave lens is also a diverging lens. Diverging lens means that the image is going to get spread apart. Right, the refracted rays are going to get spread apart. A double convex lens is a converging lens. The converging lens then focuses the image on one side. Now, to draw your image or locate your image in a diverging lens, you will, and I'm just going to draw a rough sketch here, and we'll show what happens in another image in the next slide. But your first ray, which is going to be green here, it's going to travel parallel to the x-axis, or the principal axis. When it hits the optical center, it's going to reflect in such a way that you're going to bend away. So this is your refracted, I said reflect before, so this is your refracted ray. It's positioned in such a way that it would move back and go back through that focal point on the same side as the image. Incident ray coming in, right, this is your incident ray coming in here. It gets refracted. It gets refracted at such an angle that it would actually go back through that focal point on really the primary principal side, or the same side as the object. That would be one ray we could draw to locate the image. Another ray you can draw is a ray that's going to come in. So we'll draw this one in purple. This ray is going to go in such a way that it's going to go through the focal point on the secondary side. Now, on the secondary side, it is virtual. That's a virtual line. It will cause, at this junction point, it will cause this ray, the purple line, as it's coming in here, so this is the incident. As it comes in, it gets refracted in such a way that it runs parallel to the principal axis. That line then gets stretched back and becomes virtual on the same side as the object. So two rays, right? One ray is running parallel. It refracts in such a way that it will reflect back, or sorry, move back through the focal point. So this is the refracted ray. It's positioned in such a way that you would extend this line all the way back to the focal point on the same side as the image. The second ray is the purple line here. So you have your incident ray coming in. It refracts, so it is now perpendicular to the principal axis on the secondary side. That line is then extended backwards and becomes the virtual on the object side. We're going to use those two rays to help locate where the object's image is going to be in the next slide. But it's that kind of location that we would use for our diverging lens. Those are our two primary rays that we can use. We can also use an additional one. That additional one is going to go through the optical center. That optical center is really, you're going to have your incident ray. Nothing gets refracted because it's going right through the middle, and then it refracts right back on itself. So in total, you really have three rays. One's incident ray that starts off parallel and then gets refracted in such a way that it would extend back to the focal point on the principal side, primary principal side, or the side where the object is. The other incident ray goes through the lens, gets refracted, so it runs parallel to the secondary principal, and then can get extended back. That parallel line gets extended back on the object side as a virtual image. And then the third one, which we don't necessarily have to use, but it is present, that third one goes through the optical center. Because it goes through the optical center, it does not refract at all, and so the incident ray, the refracted ray comes right back on the incident ray, very much like the converging lens. So, images in diverging lenses. Again, if we were to talk about salt again, images are always smaller, they're always upright, and they will always be virtual. That's the same characteristics no matter where you put that image, because when you are locating an image, so for example, this is our object on this side, we will be looking from this side, so the non-object side. So we're going to be looking back through the lens. That's how we are going to see our image. That image is going to be virtual because our image is going to end up being on the same side as our object, which, if you think back to the thin lens equation, that was an important part of knowing whether it was negative or positive. Is it a diverging lens or a converging lens? Converging lenses are producing real images. Diverging lenses are producing virtual images that are on the same side as the object. So to locate that, so I'll just take some of this away. Again, if I take my image, and so again I'll use a yellow line here, so we're going to draw one that is parallel, goes through the center. It's going to refract in such a way that the refracted ray, if extended backwards, would go back through the focus point or focal point on the object's side. So this is our incident ray, this is our refracted ray. Our refracted ray is at that angle because if I extend it backwards, it will go back through that focal point. Now, on the object side, I want to show that this is our virtual side, so I'm going to make a dashed line. The second ray that goes through, and we'll just draw this one blue, the second ray that goes through is going to again start from the top. It's going to hit the optical center. It's going to hit the optical center in such a way that it would extend. So if I extended this line, it would go through that focal point. But on this side, we are going to draw it as a virtual, because this incident ray that we just drew, it comes in, it's going to go into the lens, it's going to refract, but it refracts in such a way that you're going to get a line that is parallel to the secondary side, so the secondary axis. That line, I'll just take these arrows away here just to clarify what's happening. So I'm going to take this line that's parallel. That line also gets extended backwards. On the object side, it is virtual. So we're going to draw dashed lines here. Where it intersects, so right here, is where I'm going to draw my image. So I'll just take that circle away. So I'm going to draw my arrow right here. That arrow is virtual. It is upright. And it is smaller. When I'm looking for the image, I am looking from this side. That's my perspective. So you will have an opportunity to try both diverging mirrors as well as diverging lenses tomorrow in class. You're going to set up an optics bench, locate your images, get an idea of what you're looking for, kind of put a real life application, so using those lenses, and compare it to what you would see or what you've seen in this video in terms of where that image is located. So remember that diverging mirror, right? The objects, the image is going to be located on the non-reflective side. It's going to be that virtual image. Diverging lenses are also going to be a virtual image, but again, you are looking from this perspective. So this is the object side. You're going to be looking from the non-object side and trying to locate that image. Trying to figure out what the image is going to do in relation to where the focal point is, or 2F or between 2F, we don't need to worry about. That's something that we do for converging lenses. But for diverging lenses, we're just concerned with what's the basic diagram, basically where does the virtual image get located, and then we're just going to put that into practice in the lab.